Simple Harmonic Motion by Eniola Kaylee and Kaylee Griswold. Some basic background for you. Amplitude is the maximum displacement from equilibrium. When at amplitude, potential energy is at its maximum. Equilibrium is the point where forces are equal. When at equilibrium, velocity is at its maximum, and so is kinetic energy.
Period is the time it takes for one cycle of motion or for one oscillation. An example of oscillation would be when the moon orbits around the Earth. Frequency is the number of oscillations per unit of time.
Here are the units we're going to be using today. G is accelerations due to gravity. It is always 9.8 meters per second squared on Earth. The unit is meters per second squared. T is period or time. Its unit is seconds. L is the length of the pendulum. Its unit is meters.
The formula we will be using today is T equals 2 pi multiplied by the square root of length over gravity.
So,
a tire swing has a period of 2.5 seconds. A, how long is the swing here on Earth? B, if the tire swing was taken to Mars, where gravity is 1.6 meters per second squared, what would the new period be?
here's a diagram of the problem we just read to you. There shows the length of the pendulum and one revolution around the tire swing. One revolution is equal to 2.5 seconds. We depicted a picture on Earth and a picture on Mars.
The T, or the period, is equal to 2.5 seconds. Gravity equals 9.8 meters over seconds squared. Length equals unknown. Pi equals 3.14.
Once again, here's our equation. T equals 2 pi times the square root of L over G. T equals time, G equals gravity, and L equals length.
Again, the formula is T equals 2 pi multiplied by the square root of length over gravity. 2.5 seconds is time and is put in for T. It's equal to 2 multiplied by pi multiplied by the square root of length over 9.8 meters per second squared.
We put in 9.8 for gravity. So let's begin to solve our equation. 2.5 seconds equals 2 pi times the square root of L over 9.8 meters per second. The first thing we have to do is divide 2 pi from each side. When we divide 2 pi from each side, we get 0.398 seconds squared is equal to the square root of L over 9.8. We have to then get rid of the square root side. To do that, we will square both sides. When we square both sides, we get 0.158 seconds is equal to L over 9.8 meters per second. Now we have to isolate the L, and to do so, we multiply 9.8 meters per second on both sides. Once we finish that, we get length is equal to 1.55 meters.
Now the problem for Mars is T equals 2 pi multiplied by the square root of 1.5 meters over 1.6 meters per second squared. Notice that we plugged in the meters 1.55 for Mars, and also that the gravity changed for Mars, which is 1.6 meters per second squared.
Now let's begin to solve the problem for Mars. We are looking for period. T equals 2 pi times the square root of 1.55 meters divided by 1.6 meters squared. Notice once again we inputted the length that we found for the pendulum on Earth because the pendulum length does not change. Step 2. T equals 2 pi times the square root of 0.97 seconds. What we just did was divide 1.55 meters by 1.6 meters per second squared. Notice that the meters got crossed out and left only seconds. The next thing we have to do is take the square root of 0.97 seconds. Once we get that, we get t is equal to 2 pi times 0.98 seconds. Then all you have to do is multiply 2 pi times 0.98 seconds, and we get t is equal to 6.15 seconds.
As we come to a close on our problem, we notice that Earth's length is equal to 1.55 meters and that Mars's period is equal to 6.15 seconds. We hope you enjoyed our problem.
Bye.